Hello. So hello everyone and very good morning. I hope the audio and video is clear everyone. Is audio video clear? So very good morning everyone. We will start the session. In today's session we will be covering the singly and doubly reinforced beam. Okay. So design philosophy we have covered. So in today's session I'll be covering singly and doubly reinforced beam, and these sessions are very important for your upcoming RRB JE examination and as well as for your state PSC examination. Understood? Okay, we will start the session guys. So before starting the session, this is the Telegram channel. The annotated file of the annotated PDF of this lecture will be shared on this Telegram channel. You can scan this Telegram channel, okay, and you'll reach to my Telegram channel. Please join that. Okay, the PDF of this lecture will be available on this Telegram channel. Understood everyone? So we will start the session. In today's session I'll be covering, just a moment, in today's session I'll be covering the singly and doubly reinforced beam. Okay, clear everyone? Singly and doubly reinforced beam. So we will be covering singly and doubly reinforced beam in this lecture. So chapter singly and doubly reinforced beam. Okay, let's just start with the session. Okay, this is the first question. This is the first question. Answer this question everyone. Answer this question. What will be the correct answer? Everyone who are watching this class, please answer this question. The question is, the maximum area of tension steel in a beam shall not exceed. So in today's session I'll be covering the codal provision for beam, and in next class I'll be covering the codal provision for slab, and in next class I'll be covering the codal provision for columns. Okay, so this is how we will cover the RCC. Okay. Anshu Sood, yes, the correct answer is C. Very good everyone. Now you can see the maximum area of tension steel in beam as well as maximum area of the compression steel in beam. Okay, both the values, maximum tension area as well as maximum tension area as well as maximum compression area of steel, maximum compression and tension area of steel, both values are 4% of gross cross section area. Please mind it, this is total depth. Understood everyone? And what is the minimum area? Minimum area is AST upon BD, AST minimum upon BD. Okay, BD is equals to 0.85 upon Fy. Now answer me, here the D value is the effective, or here please remember that this D value is effective. Okay, it is not total depth. So for minimum area you need to consider the effective depth, but for maximum area you need to consider the total depth. Understood? So the question answer for this question is option C. Now moving ahead with the next question, please answer this question very carefully. The size of the rectangular section. Now this is also a very good question. Please answer this question very carefully. the size of rectangular section is fixed, and the moment of, now for a rectangular beam, okay, the section you have fixed, understood everyone? The size of the rectangular section is fixed, and the moment of resistance of singly reinforced section is less than design moment. So you can see the size you have fixed, there is no way you can change the size of the beam, understood everyone? And the question states that, and the moment of resistance of singly reinforced section, the moment of resistance of this section is less than, okay, is less than design moment. Understood everyone? Is less than design moment. So the moment which is coming on the beam is more than the moment of resistance. So what you will do? You will go for over. Now there is only one option, that you can change the area of the steel. Either you go for under reinforced, over reinforced, doubly reinforced, or compressive. You will go for doubly reinforced. Understood everyone? Code suggests that you go for doubly reinforced. Understood? In order to increase the moment of resistance. So there is no option to change the section. So you will go for doubly reinforced section. So our preference is to go for doubly reinforced either than over reinforced. Understood? So this is how we will solve the question. In the next question, please solve this. A simply supported reinforced cement concrete beam shall be deemed to be deep beam. Now this is a good question. Which beam is said to be deep beam? Which beam is said to be deep beam? Now I'll show you. This is one of the beam, and this is one of the beam. You can see the difference of diagram in both the diagram. This is a deep beam. Okay, so deep beam, a simply supported reinforced, this is a simply supported reinforced cement concrete beam shall be said to be deep beam if its effective span to depth ratio. Now you can see very carefully, for deep beam, span to depth ratio is in the range of 2. For simply supported beam, it is 2. It means that the span is just twice of the depth for simply supported. For simply supported beam, it is 2, and for continuous beam, a beam is said to be deep beam when span by depth ratio is 2.5. So the correct answer will be option C. Understood? The correct answer is option C. Now please remember, this depth is overall depth. Here the depth is overall depth. Understood everyone? And deep beam is designed for we'll solve one more question on this. Okay. Understood everyone? Written everyone? So the span, the effective span to the depth, overall depth, this ratio is span to overall depth. This ratio is, okay, this ratio is 2 for simply supported and 2.5 for continuous beam. I hope you have understood this point. Now moving ahead with the next question. Answer this question, guys. The deflection of beam and one-way slab can be controlled by using the appropriate. This is also a simple question. Answer this. What will be the correct answer? This is a very simple question. Now, the deflection of beam and one-way slab can be controlled by using. So deflection of the beam can be, now this is a serviceability criteria. Yes, very good. So deflection of the beam is in the permissible limit when span by depth ratio, this for span up to 10 meter, the span by depth ratio, okay, for cantilever, for simply supported and for continuous. So it is 7, 20 and 26. So 7 is for cantilever, okay, 20 is for simply supported and 26 is for continuous. Understood everyone? I hope it is clear. Understood? We'll move towards the next question. So span by depth ratio is the correct answer. Answer this question. Answer this question. What will be the correct answer? What is the correct answer for this? Now you can see very carefully the basic value of span to effective depth ratio for a span up to 10 meter for a continuous beam. Now as per IS 456-2000 for a continuous beam, just now I have written this, the correct answer is 26. Understood everyone? Now moving towards the next question. This is a good question. Okay. So no criteria is given and you are asking about the maximum Now this is a good question. Please answer this very carefully. What will be the correct answer? Very good. Very good. Because there is a confusion of span by 250 and span by 350. Okay, there are two codal provision. Let us suppose this is a beam. So what is the maximum permissible deflection? Okay, what is the maximum permissible deflection? Now you can see very carefully if you consider all the loads, temperature, effect of creep. Now look very carefully. If you have considered all the loads, temperature, okay, effect of creep, then the maximum permissible deflection from the cast level, this is the cast level. Let us suppose the beam have deflected like this. So what is the maximum permissible deflection? You can see from the cast level, this have moved to this level. Understood everyone? So if you have considered the effect of load, creep, temperature, see maximum permissible deflection is span by 250. But if let us suppose this beam contains some partition wall, let us suppose there is some partition wall on this beam, or let us suppose there are some finishes means tiles above this beam. Understood? Tiles above this beam. So what will be the maximum permissible deflection? The permissible deflection will be less because there are some partition wall. So deflection is span by 350 or 20 mm, whichever is less. So among both the values, which is the maximum? Span by 350. Understood everyone? Abhishek, not smoothen by. This is not steel structure. Smoothen means, देखो smoothen तब होता है जब क्या होता है आप steel structures में smoothen और machined की बात करते हैं. This is the RCC structure. Understood everyone? So we will talk about the finishes. Finishes means you have placed the tiles above it, not smoothened. Understood everyone? Okay. So here among these two values, what is the maximum? Span by 250 is the correct answer. Clear everyone? Now moving towards the next question. Answer this. Side face reinforcement shall be provided in the beam when the depth of the web in the beam exceed. So this question already we have covered. Okay. So when you give the side face reinforcement, whenever the depth of the beam exceeds, understood? Side face reinforcement shall be provided in the beam when depth of the beam web in the beam exceed. This question we have covered. So the depth of the beam exceeds 750 mm. So how much reinforcement? 0.1% of the web area we will provide at a maximum spacing of 300 mm. At a maximum spacing of 300 mm. Yes or no? Okay, this we have already covered. Option B is the correct answer. So most probably you will find some easy question in today's class because already we have covered in the 4 lectures. Okay, so the basics of this chapter we have already covered in the starting 4 lecture. Understood everyone? Now in tomorrow's most probably in the next class we'll be covering the concepts of slab. Okay, that is very important. Slab and columns are very important. Clear everyone? Now moving ahead, please answer this question very carefully. Please answer this. This is a very good question. Okay, a simply supported Now this is a very good question. Please put a star mark on this question. This is a fantastic question. A simply supported reinforced concrete beam having clear span of 5 meter and support width 300 mm has the cross section as shown in figure. This is the cross section which is shown in the figure. What is the effective span of the beam as per IS 456? This is a very good question. Effective span you are asked. Very good. Very good, Sachin. Very good. Good morning, bhai. Good morning. Very good. So this is the question of simply supported. A simply supported RC beam. So this is a simply supported RC beam. Okay. Having clear span of 5 meter. Look very carefully. Clear span of 5000 mm. 5000 mm. This is the clear span. Okay. The support width is 300 mm. The support width are 300 mm. Here also the support width are 300 mm. Yes or no? 300 mm is given in the question. Okay. What is the effective span of the beam? So effective span of the beam is L plus D or L plus W by 2 plus W by 2, whichever is less. Okay. So L plus D as well as now you can see very carefully. So here 400, now you can 400 mm is the effective depth. Okay, so this you need to consider the effective depth, L plus D or L plus half of the width on both side, understood everyone? Yes or no? Half of the width and half of the, it means center to the support. Okay, minimum of both the values. So L means 5000 plus 400, and here also the length is 5000 plus W by 2 means 300 by 2 plus 300 by 2. So you will get the answer as 5300. Here you will get the value as 5400. So what is the minimum value? Minimum value is 5300. Option A is the correct answer. Understood? Clear? Moving ahead. This is a good question. Deep beams. Answer this question. What are deep beams? Now you can see आप लेट हो गए भाई, जस्ट अभी मैंने बताया था. If the span by, now if let us suppose this is the beam, one of the beam is like this, there the span is more but depth is less, span is more but depth is less, but here the span is less but and depth is more. So span by depth ratio, if span by depth ratio is, let us suppose 2, okay, for simply supported beam, if span by effective span by total depth, this depth here is total depth, if the effective span to the total depth ratio is 2, it is beam is known as deep beam. And for continuous beam, if this value is 2.5, then the beam is known as deep beam. Understood? So deep beams are designed for, okay, they are designed for bending moment, but they are checked for shear force. Understood everyone? Sachin, उसके लिए I have taken one question in slab. Okay, from that question I'll take the data, then only you will be able to understand. Okay, so wait for next class. Clear everyone? So they are designed for bending moment. Deep beams are designed for bending moment, but they are checked for shear force. Clear? Moving ahead. This is a very good question. Please put a star mark on this question. For a simply supported beam of span 12 meter, now here the span is more than 10 meter. Understood? Here the span is more than 10 meter. The basic value of span to effective depth ratio. For simply supported beam, you can see the span by depth ratio. The span by depth ratio is equal to, for simply supported beam, it is equal to 20. Understood? It is equal to 20. Now, if the span is more than 10 meter, this value is multiplied by 10 upon span in meter. This value is multiplied by 10 upon span in meter. Yes or no? So 20 value is multiplied by 20 into 10 upon span in meter. Understood everyone? So this is the value. So you can see very carefully. So 6, this is 6 and this is 5, 100 by, so 50 by 3 will be the correct answer. 50 by 3 will be the correct answer. Option D is the correct answer. Yes or no? Clear everyone? So this is a good question. Here 12 you need to put in meter. So 10 upon span, which is in meter. So here the span is given as 12 meter. So you will consider the beam to be safe in deflection, that the deflection is permissible limit. The span by depth ratio is 50 by 3. The span by depth ratio will be 50 by 3. Understood everyone? Next question. In a singly reinforced balance section, if M30 concrete and Fe415 steel is used, then the value of neutral axis K in LSM. In LSM, please mind it, the value of this value is in LSM. Understood? For Fe415, what is the value of K? For Fe415, what is the value of K? So neutral axis depth factor. So x limiting value, limiting value of the depth of the neutral axis K into D. So this K value is 0.48 for Fe415. Yes or no? For Fe415. So what will be the correct answer? Option C is the correct answer. Getting my point everyone? Yes or no? Yes. Moving ahead. This concept just now we have covered. Now maximum allowed deflection in simply supported RC beam span L under uniformly distributed load including long-term elastic and shrinkage effect. Now whenever you have considered the shrinkage, creep, load, temperature, these effect you have considered, what is the maximum permissible deflection? Maximum permissible deflection in this case is nothing but L upon 250. But whenever you have considered the partition also, whenever you have considered the effect of creep, shrinkage, load, temperature, okay, then the value is L upon 350. Then the value is L upon 350. But here you are asked with only with the shrinkage effect. Understood? So your answer will be option B. Okay. Understood everyone? Whenever finishes, partitions are there, then it is L by 350. Clear? Next question. Please answer this question. The maximum area of tension reinforcement required for a rectangular beam of section, okay, 25 mm effective cover. This is also a good question. What is the maximum area of tension reinforcement? Apply your logic. Apply your logic. What will be the correct answer? Now, without calculator, you need to solve the question. The minimum area of tension reinforcement. So, AST upon BD. This will give you, this is the effective depth, is equals to 0.85 upon Fy. So, you can see what is the minimum area of tension reinforcement? 0.85 into BD. BD. Width is nothing but, width is 200 and depth is, the effective cover is given as 25. So this will be 375, okay, upon Fi. What is the grade of the steel? 415. This is your answer. This is your answer. You can see very carefully. Now you need to solve this question by without calculator. Will you be able to solve it without calculator? Now you need to apply the logic that. Now apply the logic is, you can see very carefully. Now the option here is also nearby. Option here is also nearby. If let us suppose options are wide in the range, you can consider this as 0.85 into 200 into 375 upon, let us suppose if this is 400. So this is nothing but half, this is nothing but 0.42. It means 40% of 375. 40% of 375. Yes or no? 40% of 375. This is how you will answer the question. Clear? So roughly around you will get the values as, so you will get the value as 164. Clear? Either you have the virtual calculator, you can solve the correct value. But if you do not have the calculator, you need to apply the logic in order to get the answer. Now moving ahead with the next question. Answer this question. Answer this question. Now for this question, if it is asked in JEE examination, these questions are those which you need to skip because it will take a lot of time to find the ultimate moment of resistance. Ultimate moment of resistance in LSM. You can see Fe 250 bars are there, okay, as well as width is there, depth is there, M20 grade of concrete, 4 bars of 25 mm. So here you will get the ultimate moment of resistance. You need to find the ultimate moment of resistance. For this, depth of neutral axis you need to find out, then you need to find out the moment of resistance. So this is a time consuming question. Whenever these type of questions comes in the examination, you know the solution, but it will take a lot of time for the calculation. Hence it is advisable to skip those questions and attempt in the last whenever you have the time. Clear? So ultimate moment of rest, first you will find out whether this section is under reinforced or over reinforced. First find out whether this section is under reinforced or over reinforced. You can see, you can compare the compression force to the tension force. 0.36 FCK B into XU is equals to 0.87. Okay, 0.87 FI into AST. 0.36 FCK B into XU is equals to 0.87 FI into AST. So from limit state method you will compare this. So XU will get the values as 0.87. What is the value of FI? FI value is nothing but 250. Okay. What is the AST? How many bars are there? 425 mm. So 4 into pi by 4 into 25 square. Okay. Upon 0.36. What is FCK? FCK is nothing but it is given as M20. Okay. What is the width of the beam? Width is nothing but 300. So here you will get the value as XU. You will get the value as XU. What will be the value of XU? XU here will be 197.71. So you will get the values as 197.71 mm, and then you will compare with limiting value of neutral axis. The limiting value for Fe250 is 0.53D. 0.53 D. So 0.53. What is the effective depth? Effective depth is 550. So here you will get the values as 291.5. 291.5. So neutral axis is above the 291.5 mm. So neutral axis is above the neutral axis. Yes or no? So the section is under reinforced. Section is under reinforced. Yes or no? Clear everyone? Yes or no? So it is the under reinforced section. Please answer me. You will calculate the moment of resistance from the tension side or from compression side. If it is a under reinforced section, you will calculate the moment of resistance by taking this neutral axis depth from tension side or from compression side. Very, very good. From tension side. Now the next question is, you need to find the moment of resistance. 0.87 Fi into AST, that is the tension force. And how about the lever arm? D minus 0.42 XU. D minus 0.42 XU. You will get the answer. Clear? You will solve the question. You will get the answer as 200. 0.87 Fi into AST into D. D minus 0.42 XU. D is nothing but 550 minus 0.42 XU. XU is nothing but 197.71. Clear? In order to convert this in, this will be in Newton. This will be Newton mm. So in order to convert this, 10 power minus 6, you will get the answer in kilonewton. You can solve this. Okay, you can solve the question. Moving ahead. Answer the question. In which condition a doubly reinforced beam is used? Answer the question. In which condition doubly reinforced section is used? doubly reinforced beam is used? So it is a answer this question. In which condition? No, doubly reinforced section is used when, doubly reinforced section is used when, now what is the correct answer? Whenever you have constrained by not changing the width and depth of the beam, and there is a moment which is acting on the beam is more than moment of resistance. So what you will do, instead of increasing the size, you will increase the area of reinforcement by giving the doubly reinforced beam. Understood? In which condition doubly reinforced beam is used? So what will be the correct answer? When depth and width of beam have to be restricted in size. Okay, understood everyone? Clear everyone? Next question. Answer this question. Please put a star mark on this. One of the criteria of the effective width of the flange of T beam is, width of the flange is equals to I naught by 6 plus BW plus 6 time of DF. Here what is I naught? This is a very good question. Although you used to remember these formulas, the effective width of flange, one of the critical section for effective width of the flange of T beam. Now you can see in T beam what happens is, the fibers in the center have more stress as compared to the outer fibers. So what we do is, we take the effective width, effective width of flange, okay, effective width of flange, we take the effective width such that all the fiber have equal stress in these. So okay, so by taking the effective stress of the effective width of the flange, our calculation becomes simple. Clear? So what is this? So here you must have studied L by 6 plus BW plus 6 time of DF. So what is this value? Yes, very good. This is the distance between point of zero moment. Understood? Effective span of T beam is not the correct answer. Distance between points of zero moment in the beam. Yes, this is the correct answer. Distance between points of zero moment. Understood? Clear span of the beam is not the correct answer. Distance between point of maximum moment is not the correct answer. Option B is the correct answer. Distance between points of zero moment in the beam. Clear everyone? L naught by 6 plus BW plus 6 time of DF. Okay. Can you answer me? This is for T beam. Can you answer me for L beam? Okay. L naught by 6. So width of the flange, effective width of the flange is nothing but L naught by 6 plus BW plus width of the web plus 6 time of depth of the flange. This is the depth of the flange, and here this is the width of the web. This is the width of the web. Understood everyone? For L beam, yes, very good. L beam, the value is nothing but L naught by 12 plus BW plus 3 time of DF. Okay, for L beam, the effective width of flange is nothing but, this is nothing but L naught by 12 plus BW plus 3 time of DF. This you need to remember. Okay. Yes, this is the answer. Moving ahead, solve this question. What is the correct answer? Two planks each of 50 and 50 mm section are glued together along the length of the section. Okay, along the length to form a section 50 into 100 mm. So there are two sections. Okay, there are two sections 50 by 50, so that the cross section will become 50 into 100. Okay, this is 50. One of the section is glued. This section 50 and this section is also 50. They are glued to form 50 by 100 mm and use as a beam. If the shear force at a section is 1000 Newton, what is the maximum shear stress at the glue? Maximum. First you find out the average shear stress, then you find out the maximum shear stress is for rectangular section. Maximum 3 by 2 times of the average shear stress. So what is the value of average shear stress? 3 by 2 times of V upon V is nothing but 100 Newton. So V acting here is 100 Newton. No, sorry, 1000 Newton. 1000 Newton. So what is the area? Area here is 50 into 100. So this was the concept. This was the concept. So what will be the correct answer? 3 by 2 times of the 1000 divided by 50 into 100. You will get the value as . So 2 times of 50. 2 times of 50 is 100. 100 into 100. 100 into 100 is 0.3. You will get the answer as 0.3 Newton. 0.3 Newton per mm square. Megapascal. Option B is the correct answer. Yes or no? Option B is the correct answer. Moving ahead. Now, if it is a circular section, can you give me the answer? For circular section, in order to get the ratio of maximum to the average stress. Here, maximum to the average ratio is 3 by 2. For circular section, please answer me. For rectangular section, the ratio of maximum shear stress to the average shear stress is nothing but 3 by 2. Okay, what is the value for circular section? The ratio of maximum shear stress, it will be 4 by 3. Very, very good, everyone. Very, very good. 4 by 3. Understood, everyone? 4 by 3. This you need to remember. Okay. Now, the next question. Answer this. The next question. If D and N are the effective depth and the depth of neutral axis respectively of singly reinforced beam, the lever arm. Very simple question. Lever arm is what is the correct answer? What is the value of lever arm? Simple question. Effective depth is D and the depth of neutral axis is N. Okay. Yes, very, very good. There is the standard value D minus X by 3 or N by 3. Option D is the correct answer. Next question. A T beam behave like a rectangular beam of width equal to its flange if neutral axis. This is also a good question. Now you can see I'll make this question little tough. A T beam behave like a rectangular beam. Now you can see this T beam behave like a rectangular beam. Okay, whenever the depth of the neutral axis, when neutral axis lies in the flange portion. Understood everyone? Now whenever the neutral axis lies in the flange portion and there is a sagging bending moment, please remember this, if there is a sagging bending moment, this area will be in compression and the area below the neutral axis you will neglect it. So there is this behave as effectively as rectangular beam, yes or no? And width of the flange is, this width is equal to width of the flange, yes or no? Understood? Now answer me if there is a hogging bending moment. Now answer me if there is a hogging bending. Same scenario, the neutral axis lies in the flange portion. Now answer me the width. So here this will behave as a rectangular beam. Now answer me if there is a sagging bending moment. So this beam will behave as a rectangular beam. This beam will behave as a rectangular beam of width of the flange. Yes or no? But if there is a hogging bending moment, and depth of neutral axis is more than depth of flange, Now you can see if this neutral axis is below this and there is a hogging bending moment, so what will happen? At bottom there is compression and above it there is a tension. So that beam will behave as a rectangular beam of width of the web. Okay, this is also one of the concepts which can be asked in the examination. Very beautiful concept. Clear everyone? TBA when remains within the flange. The correct answer is option B. Understood everyone? Moving ahead. Answer this question. Shrinkage deflection in case of rectangular beam and slab can be eliminated by putting shrinkage deflection. This is also a good question. Please put a star mark on this. Now you can see shrinkage deflection in case of rectangular beam and slab can be eliminated by compression steel equal to tension steel, compression steel more than tension steel, compression steel less than tension steel, compression steel 25% more than tension steel. Now you can see very carefully in if the reference is shrinkage deflection. Now shrinkage is from all the sides of the from all the surface area of the beam, yes or no? Now if let us suppose in order to resist the shrinkage there is steel bars, so you will provide the equal area of steel on both the sides. Hence in order to prevent the shrinkage deflection, if you provide the compression and tension steel equal, they will resist the shrinkage. So hence option A is the correct answer. Understood everyone? Option A here is the correct answer. Moving ahead with the next question. Answer this. A rectangular beam with width B is equals to 200 mm and effective depth D is equals to 300 mm is subjected to limit state shear of 80 kilonewton. Please answer this. This is a very good question. Equivalent value of shear. I have just given you the formula. Equivalent value of shear is nothing but VU plus 1.6 T by B. Yes or no? 1.6 T by B. Without calculator, can you be able to solve the question? Shear value is 80 kilonewton. So shear value is 80 kilonewton plus 1.6 time of the torsion moment is 6 kilonewton meter. Upon what is the width? Width is nothing but 200 mm. 200 mm. So solve the question. Now here you need to convert this 200 mm into meter. Then only you will be able to get the answer in kilonewton. So 200 mm into 10 power minus 3 is in meter. Okay. What is the correct answer? Yes, without calculator you need to solve the question. Answer will be yes, 128. 128 kilonewton. So just remember this. Here the B value should be in meter. Then only you will get the answer in kilonewton. Understood? Moving ahead, answer this question. This is one of the best question or one of the important questions for your examination. Horizontal spacing we have seen. Here in the question you are asked with the minimum vertical spacing of the main reinforcement. So if let us suppose this is the beam and this is one of the reinforcements. Here also you have provided reinforcement. So what is the spacing between this is spacing, this maximum spacing. So here you are asking about the vertical spacing. Understood everyone? The minimum vertical spacing of the main reinforcement RCC beam is the diameter of the largest bar or 5 mm more than the nominal size of aggregate of the coarse aggregate. Okay, this is the spacing for horizontal. Okay, the diameter of the larger bar or 2/3 of the nominal maximum size of the coarse aggregate, 5 mm more than the diameter of the bar, 15 mm. What will be the correct answer? What will be the correct answer then? Yes, very good. This you need to remember. Okay, larger bar 15 mm as well as okay, this value is larger bar, thicker bar, diameter of thicker bar. Okay, or 15 mm. Or 15 mm. That should not be more than 15 mm. Understood everyone? As well as the third value is 2/3 the nominal size of the coarse aggregate. 2/3 of the nominal size of coarse aggregate. Nominal size of coarse aggregate. So among these three values, maximum value you have to take. Understood everyone? Yes or no? So the correct answer is option B. Answer this. Answer this question. The maximum diameter of the reinforcement bar in RCC beam is limited to maximum diameter. What is the maximum diameter of the reinforcement bar in RCC beam? So these are very important question. What is the maximum diameter of bar you can use in beam, column, slab? Answer this. Here you are asked with the maximum diameter of the bar. Answer this. The maximum diameter of the reinforcement bar in RCC beam is limited to 28 mm, 40 mm, 1/10 of the depth of the beam, 1/8 of the least dimension of the beam. Very good. The correct answer is 1/8 of the least dimension of the beam. Least dimension of the beam. So what is the minimum of B or D? 1/8 of it. 1/8 of it. Hence option C is the correct answer. Option C is the correct answer. Understood everyone? Please remember this. Please remember this. You will get the question. Now moving ahead. Next question. This question we have already covered. Answer the question. Answer the question everyone. The limiting value of moment of resistance for a rectangular beam. So what is the maximum moment that a beam can resist? Limiting value, limiting moment of resistance for a rectangular beam of reinforcement Fe415. So for here you can see for Fe250 we have seen the value, for Fe415 and for Fe500. What is the value for? So here you are asked with Fe415. So it is 0.138 FCK BD square. How about Fe500? What will be the correct answer? For Fe500 it is 0.133 and 0.148 FCK BD square. And here 0.133 FCK BD square. Understood? So you'll get the answer as for Fe415 0.138. 0.138 is option D. Understood? Yes. Now moving ahead with the next question. Answer this. Answer this question. In a doubly reinforced rectangular beam, okay, in a doubly reinforced rectangular beam, the allowable stress in compression steel is allowable stress in compression steel. Okay, so this is the question of working stress method. Answer this. In a doubly reinforced rectangular beam, the allowable stress in compression steel. What are the values for compression steel? You take any of the value, Fe250, Fe415, you take any of the value, then answer me what is the permissible stress in compression steel and in tensile steel. Compare it with steel and now if you see Fe415, let us suppose I have take the value of Fe415. What is permissible stress in steel in tension? Okay, what is permissible stress steel in tension? The permissible, so here the values are 230 and 190. 230 and 190. Yes or no? Here the value is 230 Newton per mm square and 190 Newton per mm square. 230 Newton per mm square, as well as here it is 190 Newton per mm square. You can take any of the value. If you want to take any of the values, Fe500, Fe250 as well as Fe345. For Fe345 also it will be Fe345. What is sigma ST and sigma SC? Here also sigma SC is less. Here also sigma SC is less. So permissible in steel is 190, 130. 190 Newton per mm square. Here 130 Newton per mm square. Yes or no? So always equal to the permissible stress in steel in tension or less than or more than. So answer me now. Now what will be the answer? Less than the permissible stress in tension in steel. Option C is the correct answer. Here option C is the correct answer. Understood everyone? Now solve this question. Just a moment, I'll be back in just 1 minute. What is the correct answer? For cantilever of effective depth of cantilever depth is 0.5 meter. The maximum span to satisfy vertical deflection limit is. So span by depth ratio is. This is a very simple question. What is span by depth ratio? The answer is 3.5. Yes. For cantilever, the ratio of span by depth ratio is nothing but 7. Okay, span is given, depth is 0.5. So what is the span? Span you need to take is 7 times of 0.5, that is 3.5 meter. 3.5 meter. Option A is the correct answer. Moving ahead. Answer this question. The behavior of an over reinforced beam is more ductile than that of under reinforced beam because over reinforced beam contain. Very simple question. The behavior of over reinforced beam is more ductile than that of under reinforced beam because over reinforced beam contain more steel and steel is more ductile than concrete. Concrete brittle. Both concrete and steel stretch simultaneously. Statement is wrong. Now this is a very good question. Very good. Real site experience, you have given the correct answer. Now the behavior of over reinforced beam is more ductile. Now you can see whenever there is a over reinforced beam, what is the type of failure? There is a brittle failure, or whenever in over reinforced beam, you can see very carefully. In over reinforced beam, what is the type of behavior? It is ductile failure or brittle failure? It is ductile failure or brittle failure? The behavior of over reinforced beam is more ductile than under reinforced beam. Is the statement correct or wrong? As compared to under reinforced beam, in under reinforced beam, the failure is due to the steel, and that failure is ductile failure. But here the behavior of over reinforced beam, now in over reinforced beam the failure is brittle, so it is not, the failure is brittle. Understood everyone? So is the statement correct? Is the behavior of over reinforced beam is more ductile? Is the statement correct? No, it is wrong. Hence the statement is wrong. Understood everyone? Yes or no? Now next question. This we have seen already. Answer it. As per IS 456-2000, for the design of reinforced concrete beam, the maximum allowable shear stress depends on maximum allowable shear stress, tau C maximum. Tau C maximum. What is the value of tau C maximum for LSM? For LSM, M20, M20, M25, M20, M25, M30, M35 and M40 and above. Okay, M35 2.8, 3.1, okay, 3.5, 3.7, and here M40 and above, this value is 4. So this depends only on grade of concrete. Grade of concrete is option D is the correct answer. Yes or no? Option D is the correct answer. Are you getting my point everyone? Moving ahead, solve this question. IS 456-2000 recommends to provide certain minimum steel in RCC beam. Yes. Why minimum steel reinforcement is provided? Why there is a need to provide minimum steel reinforcement? Answer this. to avoid rupture of steel in case of flexural failure, to ensure compression failure, to hold the stirrup in position, to provide enough ductility to the beam. Answer this question. Now, although the correct explanation is not given in the question, now please remember, although the correct explanation is not given in the question, why one of the reason is because of the shrinkage. Because of the shrinkage, the stresses are developed. Because of the shrinkage, there are some stresses developed. So to prevent those stresses, to resist those stresses, minimum reinforcements are provided. Minimum reinforcements are provided. Understood, everyone? But the statement is not given in the question. But yes, among all the statements, we'll try to figure out what is the correct explanation. IS 456-2000 recommend to provide certain minimum steel in the RCC beam. Now, why minimum reinforcement? Let us suppose minimum tension reinforcement is given. Only the tension reinforcement. So one of the statement is wrong. To hold this stirrup in position. This is wrong. This is wrong. Understood, everyone? Why this minimum is given in order to hold the stirrup is wrong. To ensure compression failure. To ensure compression failure. Why it is given to ensure failure? No, it is also not wrong. It is also not correct. Now the option lies in option either A or D. Now you can see, to avoid rupture of steel in case of flexure failure occur, to provide enough ductility to the beam. Now both the statements seems to be right. To provide enough ductility to the beam, or to avoid rupture of steel in case of flexure failure occur. To avoid rupture of steel in case of, whenever there is a flexure failure, there are minimum reinforcement which will avoid rupture of the steel. Please put a star mark because there is a confusion. Both the statements are correct. Option A and D, both are correct. Both are correct. Clear? Now moving ahead. Answer this. No, this is by far the best question of today's session. By far, this is the best question for today's session. Okay. Unfactored maximum bending moment at a section of a reinforced concrete beam are 50, 80, 120, 180 kilonewton under dead load, wind load and earthquake load respectively. The design moment as per IS 456-2000 for limit state of collapse. Okay, is. Now, there are unfactored maximum bending moment at a section because of the 50 is dead load. Because of the dead load, what is the unfactored bending moment? That is 50 kilonewton meter. And due to live load, it is 80. And due to wind load, it is 120. And for earthquake load, it is 180 kilonewton meter. Kilonewton meter. Now answer the load combination. First load combination, if there is dead load and live load, how much you need to increase? 1.5, 1.5. Dead load or wind load or earthquake load, 1.5 or 1.5. Understood, everyone? When all the loads are acting, you multiply it by 1.2. So in RCC, there is very less load combination. So first load combination is dead load and live load. So you multiply dead load by 1.5 and you multiply live load by 1.5. Second load combination is if there is dead load and wind load or earthquake load. So you multiply dead load by 1.5 or 1.5 by dead load, wind load or earthquake load. Wind load or earthquake load. When all the three load are acting, 1.2 times of dead load plus 1.2 times of live load plus 1.2 times of the wind load or earthquake load. So maximum among the all will be taken care of. So you can see among the wind load or earthquake load is more. Okay, so here we will take earthquake load. Here also we will take earthquake load. Yes or no? So try to figure it out. The first value. The first value is nothing but 1.5 times of 50. 1.5 times of 50 plus 1.5 times of 80. So in the next value is 1.5 times of dead load is 50 plus 1.5 times of the earthquake load is nothing but 180. Although this value seems to be higher than the first value. Now the third value is 1.2 times of the dead load 50 plus 1.2 times of the live load is nothing but 80 as well as 1.2 times of the 180. Most probably we'll get the answer from third. Most probably we'll get the value from third. You can see what is the value. Most probably we'll get the value from. So 1.2 is common. 1.2 is common. You can solve this by 1.2 as common. 50 plus 80 plus 180. 50 plus 80 plus 180. So most probably you'll get the answer from here. So 180 plus 80 is 260, 310. So 20% of 310. 20% of 310. Yes, no need to solve the question, no need to solve because it is 20% more than 310. So you'll get the answer as option B. No need to solve the, no need to solve. Why? Because this value will be certainly more than 350. Only one option is there which is more than 310. Option B is the correct answer. Getting my point, everyone? Yes, 372 is the correct answer. Understood, everyone? I hope you have understood this question. Yes or no? Clear? Now moving towards the next question. Solve this question. Solve this question. This is also a very good question. Calculate the maximum factored bending moment of rectangular factored bending moment of rectangular beam of effective span. So effective span is given as 6 meter. The superimposed load. So superimposed load is 84 kilonewton per meter. 84 kilonewton per meter. The dimension of the beam are limited to 35.5 centimeter and 75 centimeter overall. Okay, M20 Fe415 grade density of concrete is 25 kilonewton per meter cube. Maximum factored bending moment. So you can see if it is a simply supported, superimposed load is this. Superimposed load is this. So factored bending moment is WL square by 8. Factored bending moment is for simply supported beam. We consider this as simply supported beam. Okay. So this is the factored bending moment. WL square by 8. So here your task is to calculate the load. Yes or no? So your task is to calculate load W. So superimposed is 84. Superimposed is 84. Okay. As well as what is the self weight? What is the self weight? Please don't neglect this self weight of the beam. Self weight of the beam is nothing but the density of the density is 25. Okay, density is 25. Okay, here the density is 25. So what about the volume? What about the volume? For 1 meter, it is 25 kilonewton per meter cube. So for 1 meter, the length is 1 meter as well as the width and depth is nothing but, for convert this in meter, 0.35 into 0.75. 0.35 into 0.75. Yes or no? So this is nothing but kilonewton per meter. Okay, this is nothing but kilonewton per meter. Yes or no? So this is 6.6. this value comes out to be 6.6 kilonewton per meter, as well as superimposed load. So total load is this intensity is 6.6 kilonewton per meter. Yes or no? 6.6 kilonewton per meter. What is the superimposed load? That is 84 kilonewton per meter. So this is nothing but 90.6 kilonewton per meter. This is the load intensity. So the factored load is for factored load, you multiply it by 1.5. 1.5 times of 90.6. So increased 50%. 45.3. So 135.9. So 135.9. So this is the factored load. If this is the factored load, this is 135.9. What is the length? Length is nothing but, this is given in the equation as 6 meter. 6 meter square divided by 8. You will get the answer. Kilonewton meter. You will get the answer in kilonewton meter. So you will get the value as 612. Option is 612 kilonewton per meter. Option A is the correct. This question also takes a lot of time. Hence, it is advisable to leave such question for the last. Okay. Yes, the value is 612. This is also a very good question. I mean, this question seems to be for GATE examination, not for your JEE examination. But yes, how to calculate the factored load? This is what explained in this question. Shall we move ahead? Moving ahead. Answer this question. The length of the straight portion of the bar beyond the end of the hook should be at least. This is an important question. Please put a star mark on this. Answer this question. Beyond the straight portion. Now, if let us suppose this is the length of the bar. Now, beyond this, how much is the straight portion? What is the portion of this? This is nothing but 4 times of diameter of the bar. Yes or no? 4 times of diameter of the bar. Yes or no? 4 times the diameter of the bar. So the length of the straight portion of the bar beyond the end of the hook should be at least 4 times of the diameter of the bar. Yes or no? Now moving ahead. Answer this question. Last three question, guys. Last three question. What is the adoptable maximum spacing between vertical stirrup in RCC beam of rectangular cross section having an effective depth of 300 mm? So what is the distance? What is the maximum spacing? The maximum spacing in vertical reinforcement is nothing but, what will be the value? 0.75 D. Very, very good. So maximum spacing of stirrup, maximum spacing between the vertical stirrup. So this is nothing but 0.75 into D. So effective depth is value is 300. So 0.75 means 0.75% of 300 is nothing but, yes, 3 by 4. So this value will comes out to be, what is the value? 225 will be the correct answer. Yes or no? 225 will be the correct answer. So the maximum spacing should be 225 mm. Okay. Option D is the correct answer. Okay. Next. Answer this question. So last two question. Now answer me. Torsional resisting capacity of given reinforced concrete section. Okay. So whenever you increase the torsional resisting capacity, okay, for a given section, by increasing the torsional capacity for given section, you can see very carefully, decreases with the decrease in stirrup spacing. So whenever you decrease the stirrup spacing, when the spacing of the stirrups are decreased, so the torsional capacity decreases? No, it will increase because more stirrups will be there. So option A is not the correct answer. Decrease with increase in longitudinal bar. So whenever you increase the longitudinal bar, will it increase? No. Will it decrease? No. Option B is also not the correct option. Does not depends upon stirrup. It depends upon the stirrup and longitudinal steel. Hence increases with the increase in the stirrup and longitudinal steel. So whenever you increase the longitudinal stirrup as well as you increase the shear stirrup, it will increase. Option D. So only by the logic you will get the answer here. Understood everyone? Now moving ahead. The last question for today's class. 35th question. Answer it. Critical section for shear in case of RCC beam in frame building is taken at a distance. Critical section for shear. Now, what is the, as per IS code, what is the critical section for shear? If let us suppose this is the critical section for shear. If let us suppose this is the support. This is the support. Now, the crack will develop from the face of the support to the D. So, what will be the correct answer? This is given in the IS code. So, what is the critical section? So, where there is a maximum shear, okay. So, IS code assumes that here in this depth, there is a equal shear, okay. There is a equal shear. So the critical section is nothing but the critical section for shear in case of RCC beam in frame building is taken at a distance D from the edge of the support, at the face of the support, no, D by 2 from the face of the support is not the correct answer. 0.75 D from face of support where D is effective depth, no, option A is the correct answer. D from the edge of the support. Understood everyone? Clear? So I hope you have understood the concepts of the singly and doubly reinforced beam. Although we have covered the concepts thoroughly. Understood everyone? So here the question answer is, so this is for the critical section for shear in the beam, frame building, RCC beam. It is not foundation, it is beam. That is why we have taken D from the face of the edge, from the edge of the support. Yes or no? Clear? For the beam, it is not for footing. Understood? Sachin, we are asking for RCC beam. Okay. So this is it guys. This is it for today's session. I hope you have enjoyed the session. Have you enjoyed the session? So this is how we have covered the beam part. Okay. We have completed the beam part. Now we are left with 3 chapters, that is slab, column and footing. Slab, column and footing. And most probably for your JEE examination, pre-stress concrete is not important. Okay. Pre-stress concrete is not important for your JEE examination. I am expecting questions from beam and slab. Okay. And most probably tomorrow will be your off. Okay, I am traveling to some place. So tomorrow and day after tomorrow, that is on Friday and Saturday, I won't be available to take the class. If most probably I'll reach my home on Saturday evening, I'll take the session on Saturday evening. Understood everyone? So tomorrow will be off for your class. I'm traveling to some place and I'll be back on Saturday evening. So most probably if I reach on time on Saturday evening, I'll take the session on Saturday evening. Most probably at around 8 PM or 7 PM. Clear everyone? Most probably around 7 PM or 8 PM. So next class will be probably on Saturday evening or on Sunday morning. Clear? Understood everyone? And one more class I'll take on column, then your whole syllabus will be finished. As per your JEE examination, then that will be finished. Okay? Okay. Thank you so much guys. Thank you so much everyone. I hope you are enjoying the session. The questions are of very good quality. They will cover all the concepts of your RCC examination. Thank you so much guys and bye-bye. Okay. You can download this PDF. You can download this annotated PDF on this Telegram channel. Okay. Share this Telegram channel among your friend as well as share this session among your friend so that, and both, it is in very simple English language. So each and every student among Pan India can understand this session. Okay. No, why? I am also preparing for examination. This is what you think of me. Chalo, this is it. Thank you so much guys. Thank you everyone.